So my name's Kenny Blumenfeld. I'm a climatologist with the DNR. Chris, can you just confirm real quick you see my screen? Okay,
Yes, we can.
very good. Thanks. Um, so we're just going to give a basic overview of how things are changing in Minnesota, what it means for the state and what it means for the Morris area and Stevens County a bit. You're very fortunate. Dr. Roop has some really good information to share, and we have to kind of coordinate not to kind of overlap too much. But I'm really honored to be part of this ongoing symposium. Okay, so before we start, and we can't go too deep into detail about this, but the reason that we do this and not just refer you to, say, some national or international document on climate change is because the story of how our climate works and also how our climate is responding to the globally changing climate, it's different. It's not the same as what you find in California or as what you find in India. We all are reacting differently. And when I say we all, I mean, I mean, it's true that people are, but what I really mean is our climate is responding differently to the changes that are ongoing globally. And this should make sense because you know that Minnesota already had a different climate from that of California or India or Argentina. And so we want to know, what's going on here because the people make decisions here and they manage resources here. So my job is to help people understand what's happening in Minnesota. Uh, Chris kind of touched on this in the overview, and it's something we're all going to be talking about a lot more, not just today, but in the coming months and years. There's a big difference between observations and projections. Climate observations are about the past and what we've observed using instruments and equipment, and projections are based on computer simulations of complicated numerical models that simulate the atmosphere, and in particular, simulate the atmosphere in a condition where the amount of greenhouse gases have been changed or altered because of increased emissions from human activity. And this is a really important component for understanding what's going to happen in the future. And there are two things that are often confused. You might read a story that's about some kind of big climatic change finding, and it might be hard to know, are we talking about something that's already happened or something that's expected? And these pieces are actually important because you want to know where you are now and where the trends have led you till right now. And you also want to be able to consult the very best science and get a sense of where we're going. The third point is kind of this is the one that people argue about at the dinner table. Um, the fact that we have a naturally quite variable climate here. It goes up and down. It goes from hot to cold within a year. And also we have warm years and we have cool years. We have warm winters and we have cold winters. We have wet summers and we have dry summers. So we're used to a lot of variability. And that makes it hard for people to recognize sometimes that we also have ongoing trends. We are getting warmer and we are getting wetter. And the trends don't prove or disprove the variability, and the variability doesn't prove or disprove the trends. They're both true simultaneously. They don't disprove each other. And as we talk about the trends that are happening now and what we expect in the future, you have to keep in mind that that's all going to be against a backdrop of a highly variable climate. So we're still going to have ups and downs even as we continue to see systematic changes in our climate. And it's always good to stay up to date. I appreciate being invited to this. I think I was up in Morris in the fall of 2015, and I usually tell people get some new climate information every few years because the science and what we know or what we suspect, those things change occasionally. They don't change as quickly as some people might assume, but there are changes that occur not just in the climate itself, but the science of understanding the climate. So here are the two main trends in Minnesota that are tied to our change in climate. And again, this is going to be pretty simplistic for now. We're getting wetter. we're seeing more precipitation, more snow, more frequent and larger extremes. And this is something we've already observed and is projected to continue. But again, even as we've observed it, we've gone through periods of wet and dry variability, these ups and downs that are part of our climate. We're in one of those downs right now. It's been pretty dry in the Morris area, and the whole state is abnormally dry with respect to what we typically see, and we're kind of on borderline drought conditions. But this is embedded within a very wet regime, and if you just look at the last several decades, we've been getting wetter and wetter. We're also seeing increasing temperatures, and this is especially true at night and during the winter and when it's really cold. And we have this concept that you might be familiar with, kind of cold weather warming. It might be counterintuitive, but it's really where we're warming the fastest is when it's coldest. So I know we just came through a 2-week spell of really cold air, and it's hard to forgive that. But the fact is that kind of cold used to be pretty common. We used to see a lot more of it, and it used to be even more severe than what we get now. And our coldest conditions, they're less frequent and they're less severe. So these are the two main changes. We don't have time to go into what's really not changing yet, or at least what do we have our eyes on. But what's important about these is things like heat extremes and drought, although they have not worsened, and that's just a human subjective term, although they've not worsened in Minnesota yet, the projections, when we look at those numerical models, they actually tell us, give it, we don't know exactly when it would start, but give it a couple decades, and most of the models kind of flip into a mode where they're showing us getting hotter, having more heat waves, and having more prolonged dry periods while it's hot, which would spell potentially more drought. Another thing that we all like to talk about in Minnesota are those big severe thunderstorms that produce hail and high winds and tornadoes. And all we can say with respect to the climate change science is it's not clear where we've been going, because we know we're at more risk because of human habitation and taking up more of the landscape and having more property on the land and things like that. But when you look at the actual data, I would say that the consensus, or the scientific view of this, is pretty well split, in that there's a lot of evidence that tornadoes and severe convective storms could get more powerful as a result of increased global temperatures. But there's another part of that scientific body of literature that shows that they also might become less common. And it's kind of hard to know what to make of the future and exactly where we're going with that. But we know enough to know that we've gotten warmer, we've gotten wetter, we're seeing bigger rainstorms, we're seeing kind of sometimes kind of surprising conditions. So let's just get into the data now. This is a graph showing Minnesota's annual temperature averaged around the state, and Minnesota's annual precipitation also averaged around the state. So what you see is any dot just represents some year in our climate history, again, for sort of the average of Minnesota, which Morris is going to be a little bit on the drier side of that average, but it's pretty close to these values in general. And the annual precipitation goes from bottom to top, and the temperature goes from left to right. And those axes in the middle are 20th century averages. So if you see a dot in the upper right quadrant, that would be a warm and wet year. And you can see from the key in the lower right that we've only taken this up through 1986. And if you just look at the distribution through 1986, it's pretty symmetrical, well behaved. You got a couple outliers, but it's pretty symmetrical around those 20th century averages. Watch what happens when we go to the most recent 30, I can never count this right, 34 years now, when we include 2020. So 1987 through 2020, we take this big jump. So we had been symmetrical, and now we've got this big jump to the upper right quadrant. In other words, more warm and wet conditions. In fact, 2016 was the combined wettest, warmest year on record. And if you look at those other red dots, they indicate that all the other years that were sort of vying for that dubious title of being the combined wettest and warmest year were also in that most recent 34-year period beginning in 1987. You do see 2019 up there. It was our wettest year in Minnesota, although it wasn't particularly warm. That's why it's a little bit to the left of that axis. But only one of those recent 34 years was cool and dry. The other 33 were some combination of warm and wet. And of course, in 2019, Minnesota set its annual statewide precipitation record. And one year is just one year, but you can see an ongoing trend. The tendency has been for years to get wetter and wetter. And what that means is just more precipitation. This graph doesn't tell you when that precipitation is falling or how that precipitation is falling, but you see the ups and downs that are part of the variations in our climate that we expect, even as, we could draw the statistical, the regression trend line, and you could see the slope, but you can let your eyes tell you the story that would come out from that same bit of statistics anyway. We have 38 historical stations with over 100 years of record. It includes the Research and Outreach Center in Morris. It's one of our great historical climate stations. And what we can do is we can take a census of these every year and see how many days with an inch of rainfall do you get at a typical historical station. So we can hold that population of stations steady over time so we're not introducing new ones, and then we just count. And an inch of rainfall is kind of the entry level for heavy precipitation in Minnesota. You won't necessarily see flooding unless it's been really, really, really wet. But it is where you start to get things canceled, outdoor activities, and it's where you see some runoff typically, especially if it's a summertime thunderstorm. And there's been a 20 to 40% increase in the frequency of these 1-inch rainfall events over the last 105 years. Kind of depends on how you do the statistics. You can be conservative and say at least a 20% increase. And if you think of these average 38 stations and we just say, okay, well, what's the size of the typical heaviest rainfall of the year at, averaged at those 38 stations? So, and that has increased pretty dramatically from the beginning of the record in 1916 through 2020. Again, there are going to be ups and downs because you have wet years and you have dry years. You have years where lots of stations get dumped on, and you have years where very few stations get dumped on. But the predominant trend, and you can just follow that 9-year moving average, and you see that even with all the ups and downs, we're still kind of trudging our way up that hill. And these are pretty dramatic increases. And if we just look at those same 38 stations and say, what's the biggest rain each year at any one of these stations? This is where we've started to see some really big changes where, we're seeing increases on the order of up to 50% over the last 100 years. So what used to be a heaviest rainfall at any one of these 38 stations has now increased by 40, 50%. Kind of, again, depends on how you do the statistics. But just look at some of those dots way off on the high part of the right side of that graph, and they just simply did not exist on the left side. So we have gotten wetter in a way that we have not seen before. And when you kind of add it all up, more annual precipitation, so more precipitation spread across the calendar, more days with that kind of entry-level heavy precipitation. The average heaviest precipitation event of the year has been increasing, and then kind of the absolute heaviest precipitation event, kind of anywhere in the state is one way of thinking of it. It's also been getting bigger on average. And, people like talking about, well, what's happening with these big, the 100-year rainfall events? And if we take those same 38 stations and we just look at, well, what's their published value in NOAA Atlas 14 for the 100-year 24-hour rainfall, and then just add up every time that 100-year value has been exceeded at a given station. And what you see is that for the first part of the record, we were in pretty bad drought, and we just weren't where we are now. And we didn't have any of those 100-year rainfall events. They really began in about the 1950s. And since then, it's subtle, but you can see increased frequency. Just the space between those bars has generally been shrinking over time. You can see the gap between each bar on average is getting narrower and narrower as we go from the left to the right side of this graph. So that's what we've observed. Now, when we look at the kind of suite of models that were run for the National Climate Assessment and look at the ensemble from those, their projections indicate that by the middle of the century, the amount of precipitation that we have added in Minnesota is probably going to get added again. So we're not done getting wet. We would expect to keep getting wet, at least through the middle of the century. And remember, we're going to go through dry periods along the way, and but the best scientific information suggests that we're going to be getting wetter here in Minnesota, and not just wetter, but also seeing more of those heavy precipitation events, the ones that occupy the upper 1 or 2 percentile of the distribution. In other words, not necessarily the blockbuster events, but the kind that you would normally get once or twice a year. Looks like, according to these models anyway, it would be coming more like 2 to 3 times a year. And again, that's on average, which means some years you're probably not going to get any because it's really dry, and other years you might get 6 or 7. But that's a pretty substantial increase, also equivalent to about a 50% increase in frequency. Another way that we have changed is, we've been getting warmer. And this is a very simple breakdown that just shows how Minnesota has gotten warmer kind of from south to north. I'm just merging what we call climate divisions. But you can see that, Morris is in that sort of central band and pretty well represents the statewide average for temperature change historically. But if you add up all of that temperature change that we have measured, it's about 3 degrees Fahrenheit since 1895, just on an annual average basis. But when you look at the winter low temperatures, so the average night during winter is now almost 6 degrees warmer than it was when we started having homogenized climate records in Minnesota. Summertime days have been getting warmer in central and northern Minnesota, but not nearly at the same rate that wintertime lows have been going up. And so, we are warming, and this is something we're expected to see more of in the future, but we're not seeing the same rate of warming as we are with winter nights. Just down the road from you in Milan, we have an old farmstead or rural location. It's not, I don't know if it's a farmstead anymore, but they've been taking observations for 3 generations. And this is one of the best cooperative observers in the country. And we can just track the coldest day of the year or the 15 coldest days of the year. This is all what's on the graph here. And you can see, again, a steady increase in the temperatures when it's coldest. In other words, it doesn't get cold the way that it used to. You can see that by looking at some of those recent spikes on the far right. And then just if you guide your eyes left, you see how common that used to be. And furthermore, you can see spikes on the left that just don't occur anymore. So what we now think of as cold used to be pretty common. What we used to think of as really cold doesn't happen that much, if at all, anymore. And meanwhile, we're sort of seeing, with all the increased precipitation, even though winter's warming so much, we're seeing increases in snowfall in a lot of Minnesota. Now, again, you might think, well, this winter's not that snowy, but we're not talking about every winter. We're talking about a trend towards more snow. So even when you look at your dry winters and then you combine them with your snowy winters, the average is an increase in snowfall over most of Minnesota. But even as we've been seeing that, we've been seeing increases in the number of days during the snowy season between November and March, where the temperature remains entirely above freezing. So it's almost a paradox where we're getting warmer winters, we're also getting more snow during winter, but we're also getting more thaw-like conditions during that same season. And this is leading to, in some cases, less snow. We're also seeing, as is shown in this graph, and this is from Duluth, but we could show this anywhere around the state. It's just something that Duluth had requested. It took a little time to put it together, but we could do this for Morris very easily. The number of days where there's precipitation falling, but it's not snow and the temperature's above freezing, those are all metrics that are going up across the state. You can see the sort of stair-step appearance for that type of precipitation. And of course, again, there's variation from year to year, but the DNR did a big study of all of our entire lake ice database. And for the stations that had both ice in and ice out data, there's a pronounced downward trend in the length of the ice over season. I mean, yeah, we've had some really late ice seasons recently. I think this year we might have a late ice season where the ice stays on the lakes into April in some places. But on average, we've lost about 4 days per decade on a typical Minnesota lake that's of annual lake ice. So that's a lot. And this is a result of warming winter conditions and also non-snow precipitation falling during those warmer winters. And when we look at the models, we look at the projections, there's more warming that's expected. This would indicate, shorter frost seasons, longer growing seasons, of course, warmer winters. That's really our strongest change that we have. And then on this particular map, you can see more summer heat is expected too. That's not something we have observed yet. So this would be a big change. And this is also from one of the lower emission model scenarios. In other words, there's probably less warming induced on this particular model run than we're actually likely to observe. And this indicates what the map is showing is the change in the number of days per year where the high temperature exceeds 90 degrees in Minnesota by the middle of the century. And you can see those are fairly large changes. In the Morris area, it would be an increase in 10 or 20 additional days where the temperature exceeds 90 degrees. So that's a big change. We haven't gotten there yet, but this is something that as the climate continues to change that we should at least be ready for. I just want to show you real quickly, there will be some new tools available in the next couple months. This is from, and they're going to be pretty basic. It's not going to be much different from what I'm showing you, but there's been some modeling that was done by colleagues of mine and Heidi's at the University of Minnesota. They produced, they've given that data to the DNR and we put it into some databases that we have and have been trying to make it accessible using some basic tools. So what I've done here is I've selected Stevens County and I've just taken the annual temperature projections. And I know these aren't really bright right now. And that's one of the things that we're going to brighten these up. But on the left, you have the kind of average from the late 20th century. And then you go to the middle of the 20th century from it's 2040 through 2059. And you can see the average projected temperatures in that next panel to the right. And then you can go to the end of the century and then you get two choices you can look at on the left, either the kind of low emissions scenario or on the right, the higher emissions scenario. And it doesn't matter how you look at it. You could look at this chart, you could look at one that's just for winter. They all indicate by the middle of the century, 3 to 4 degrees of additional warming just in the next 20 to 30 years, basically. And then another 3 to 5 degrees of warming by the end of the century, depending on which way we go with those emissions. So even in Stevens County, we're seeing it everywhere. No one's really geographically fortunate enough to get out of this. So in summary, Minnesota is already wetter and warmer. We've had more precipitation extremes, warmer winters and warmer nights. And the projections for the middle of the century and the end of the century indicate more precipitation, further warming, a further erosion of winter, but also hotter summers too, which we have not seen yet. And just remember, variations, including extreme ones, are going to remain part of our climate, even as we see these trends continue. So we might have an extreme drought, even as we are trending wetter. And we could even get caught with some surprises where we're in a dry period, but we get a big rainfall event during a drought or during a dry spell. Or as winters continue warming, like the winter we had right up through January where we were very warm, cold spells during those warm winters will still be likely, even as we trend wetter and warmer. And we should always expect surprises that interrupt whatever the dominant trend is. So that's it for me. Thank you so much.